Hello everyone, this is Anil Reddy, Assistant Professor of Mathematics, MLR Institute of Technology, Hyderabad. Today I am going to explain about fixed point iteration method. So how to find root of equation f of x is equal to 0 and what is the fixed point, and finding root of an equation using fixed point iteration method. So in the last class we have discussed root finding methods, bisection and regular false method. Bisection method and regular false method. So these two methods are used to find root of an equation f of x is equal to 0. So how to find root we have already discussed in the last sessions. So we find an interval a comma b, and these methods, root finding technique methods, so based on intermediate value property, intermediate value theorem. So what is that intermediate value theorem? So its functional value f of a into f of b less than 0. So that means f of a and f of b are of opposite sign. So f of a and f of b, its functional value of the interval, endpoints of the functional value of the interval must be less than 0. So that means the both functional f of a and f of b are opposite sign. So then only the root lies between the interval. So this is already we have discussed in the last two sessions also. Now in the fixed point iteration method, so we require one approximate value or one approximate root. So we require one approximate root or one approximate initial value. So that is, let us say x0 is our initial approximate value, then next approximate value is x1 and next x2 and so on. So this sequence converges to root of the equation. So converges to root of equation. So this is called a fixed point iteration method. And what is fixed point? Now we have to discuss what is fixed point. A fixed point, a point x is said to be point for a given function g if g of x is equal to x. So that is nothing but if we write the given value x is equal to g of x, then x is said to be a fixed point for the function g. So we can explain this geometrically. So the fixed point is nothing but the point of intersection, right? So this is the graph y is equal to g of x and the line y is equal to x, y is equal to x. So the fixed point is means the intersection of the function y is equal to g of x and the line y is equal to x. So here we have one fixed point and the other fixed point is this one. So this is the fixed point. So for example, a fixed point may or may not be unique. If you take an example as tan x, so we can represent this geometrically. So this is the graph for tan x and we can draw a line to this. So these are the fixed points. So there exists infinitely many fixed points for the function tan x. So that means the fixed point may or may not be unique. Sometimes it may exist infinitely many fixed points for the given function. Now if you see the second example, g of x is equal to root of 2 plus x. So this is a parabola and we can write y square is equal to 2 plus x squaring on both sides. Now y square is equal to 2 plus ax. Now x is equal to, we can write x is equal to g of x. So this is equal to root of 2 plus x and x is the 2. The fixed point x is equal to 2 because x we can write as g of x. So x is equal to 2 plus 2 root of 2 plus 2, and this x is 2 and this is equal to 2. So both left and right hand are both are equal. So 2 is the fixed point for the given function g of x is equal to root of 2 plus x. Now if we see the third example, the function g of x is equal to x plus 1 has no fixed points because g of x is not equal to x. Now we will check it. So this is the graph and this is the line y is equal to x plus 1 and this is the line y is equal to x. Okay, so these two are parallel lines and never intersect. So this function does not have any fixed point. So that means it has no fixed point. So if you write this as x is equal to g of x, that means x is equal to g of x, this is equal to x plus 1. Okay, right. So if we cancel both sides x, that is we get 0 is equal to 1, but never 0 is not equal to 1. So this condition fails. So it has no fixed point. Next, finding root of equation using iteration method. So in this lecture, we will learn how to find root of equation. So this is also one of the root finding technique method, and this method is used to find a root of an equation f of x is equal to 0. This method is also called as fixed point iteration method or simply iterative method. Now we see the definition of this fixed point iteration method. F of x is continuous in the interval a comma b, and f of x can be written as x is equal to g of x, fixed point x is equal to g of x. So just now we have discussed what is the fixed point, such that this x is equal to g of x, such that modulus of g dash of x less than 1, that is the absolute value of g of x, so must be less than 1. So this condition must be hold. If this condition holds, that is convergent, so the function g dash of x must be convergent, then only the iteration method exists, otherwise it does not exist. If it is divergent, so the iteration point does not exist. So that's why we take this condition as modulus of absolute value of or maximum value of g dash of x is less than 1 for every value of x between interval. Every value of x lies between the interval I. Okay, if you take any interval, the value between that interval must satisfy this modulus of g dash of x is less than 1, converges to 1, then we say that so this method exists for fixed point iteration method, otherwise it does not exist. So we have to check this condition, then only we will apply this method. Okay, if this condition fails, fixed point iteration method does not exist. Now we will see one example on this, how it works. So before going to this, modulus of g dash of x is less than 1 for every x belongs to the interval, then x naught is equal to a plus b by 2, x naught is equal to a plus b by 2 be the initial value or initial guess. And the next approximation root, we take x1 is equal to g of x naught, and x2 is equal to g of x1, and next we can continue up to nth iteration, xn is equal to g of xn minus 1. So this process is called iteration process. And we continue this process. This process is called iteration process. And we continue this process whenever the two consecutive roots are equal, then we stop this process. Now we will see example on this process. Find a real root of x power 4 minus x minus 10 is equal to 0. Correct to 3 decimal places using fixed point iteration method. Now we know how to find a root of an equation. So based on intermediate value property, so we find let me take f of x is equal to x power 4 minus x minus 10 is equal to 0. Right, so we take the initial guess, let x is equal to 1. So that implies f of 1 is equal to 1 power 4 minus 1 minus 10. So 1 power 4 is nothing but 1 minus 1 minus 10. So this is equal to minus 10 less than 0. So the function value is less than 0. Next, if we take x is equal to 2, so that is f of 2 is equal to 1 to the power 2 to the power 4 minus 2 minus 10. So this is 2 power 4 is 16 minus 2 minus 10. So 16 minus 12 is 4. So it is a positive value. So we take greater than 0. Now the root lies between 1 and 2. So its function value f of 1 and f of 2 are opposite sign. So what is intermediate value property? F of a and f of b less than 0. So this condition holds here, f of 1 and f of 2 are opposite sign. So therefore the root lies between 1 and 2. Okay, so we take this as a and this is b. So the next approximation root. So before, this is the interval. 1 comma 2 is the interval. Okay, right. Now we have to check the condition. We have to write the given equation f of x as x is equal to g of x form. So we write f of x as x is equal to g of x for every x belongs to interval 1 comma 2. Right. Now x is equal to g of x. So we are writing f of x as x is equal to g of x form. So here x power 4, x given equation is x power 4 minus x minus 10 is equal to 0. So which implies that, so how to write this x is equal to g of x? So there are many ways, ways we can write this x is equal to g of x. So one is x to the power 4 minus x minus 10 is equal to 0. So I am taking x is equal to x to the power 4 is equal to x plus 10. So this is one way, and other way we can write it as x is equal to x to the power of 4 minus 10, and many other ways we can write this equation. But how we know exactly the root, does the sequence exists a root or not, convergent or not? If it is divergent, so the sequence does not exist. So we have to check it, which sequence exists or which sequence is converges. Right. So x power 4 is equal to x plus 10. X is equal to, I am taking x plus 10 whole to the power 1 by 4. And this is of the form x is equal to g of x form. X is equal to g of x. So here our g of x is equal to x plus 10 whole to the power 1 by 4. Now we find g dash of x. So g dash of x is equal to, so derivative of this, so 1 by 4 into x plus 10 whole to the power 1 by 4 minus 1, that is minus 3 by 4. Right. So now we can write in the next page. So g dash of x is equal to 1 by 4 x plus 10 whole to the power minus 3 by 4. Now we take a modulus of g dash of x is, modulus of g dash of x is equal to, so modulus of 1 by 4 x plus 10 whole to the power minus 3 by 4. So if you substitute any value which lies in the interval 1 comma 2, it can take 1.2 or 1.1 or 1.5, 1.6. So any value this condition satisfies. So therefore we say that, so for every x which belongs to 1 comma 2, so lies in the interval, so 1 comma 2. So we say therefore this sequence converges. So we get a fixed point. That fixed point is equivalent to the root of the iterative method. Now we can check this second one also. X is equal to x to the power 4 minus 10. So we can write this x is equal to g of x form. Okay, so write x is equal to g of x form. So x is equal to x to the power 4 minus 10. This is g of x. Now g dash of x is equal to derivative of this g of x, 4x cube minus 10. Modulus of g dash of x is equal to modulus of 4x cube minus 10, and if you take any value, for any value which lies in the interval 1 comma 2, so this value is always greater than 1 because it's a mod absolute value, so we always greater than 1. Suppose if you take one value, so 4 minus 10 is minus 6, so 6 absolute value of minus 6 is 6, so it is greater than 1. So if you take any value which lies in the interval 1 to 2, so is always greater than 1, so it is a divergent sequence. So the root the fixed point does not exist, so we cannot find a root from this sequence, from this function g of x is equal to x to the power 4 minus 10. So in this way we can find which sequence is converges to the root of the equation f of x is equal to 0. So now we continue with this function x power 4 is equal to, what is that, x plus 10 and x is equal to, so g of x. So we continue with this function x is equal to g of x. Now we take the interval 1 comma 2. So here our interval x naught is equal to a plus b by 2. So that is 1 plus 2 by 2. So this is 3 by 2, which is equal to 1.5. Now the next approximation root. We can find the next approximation root. x1 is equal to pi of x naught. So this is equal to pi of, what is x naught? Our x naught value is what? 1.5, right? So x naught is equal to 1.5, and x1, next approximation root, x1 is equal to g of x naught. So this is equal to g of 1.5. So we already know that g of x is equal to what? G of x is equal to x plus 10 whole to the power 1 by 4. So now substitute this value in this function. X is equal to, g of x is equal to x plus 10 whole to the power 1 by 4. X plus, that is 1.5 plus 10 whole to the power 1 by 4. So this value is equivalent to 1.8415. Okay, next approximation root, x2 is equal to g of x1. So this is equal to g of, what is x1 value? 1.8415. So we can take 1.8415 here. So this is equal to, so substitute in the given function g of x. So that is x plus 10 whole to the power 1 by 4. So 1.8415 plus 10 whole to the power 1 by 4, and this value is equivalent to 1.8550. Next approximation root, x3 is equal to g of x2. So this is equal to g of, what is x2? 1.8550. So substitute this 1.8550 in the function g of x. So that is x plus 10 whole to the power 1 by 4. So 1.8550 plus 10 whole to the power 1 by 4. So this is equivalent to 1.8556. So up to 3 decimal places. So these two values are same. So therefore we can stop the process. So the required root is 1.855 is the required root for the given function. So in this way we can find root of an equation using fixed point iteration method. In today's session we have discussed fixed point iteration method. In the next session, we will discuss Newton-Raphson method. Thank you.